Bang, the beginning of the universe.
A little tiny patch of space was filled with this uniform energy that gave rise to a powerful outward push that drove everything to swell enormously.
Quantum fluctuations birth an entire explosion. With rapid expansion, we call it inflation. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky.
It sounds like random static, but that buzz contains an incredible wealth of hidden information. It holds the secrets to the composition of the universe and allows us to peer into its fiery beginning.
Regions of slightly different density in the hydrogen and helium gas that formed shortly after the Big Bang.
Then it takes a little time to make your first stars. We call it the Dark Ages. Stars are made, galaxies mature. We come up to the present day, 13.7 billion years later.
The question is that model right? So I have two favorite theories. The one theory that I think is very, at least on the table, is plausible is yes, that is the beginning of the universe, and it's because time and space themselves are not fundamental. That when you get deep into the guts of quantum mechanics, you realize that all the stuff around us, the tables, the chairs, space itself, time itself, are emergent, approximate phenomena. They're like talking about the air as a fluid with a temperature and a pressure rather than talking about the molecules. Maybe even time is just a good approximation and it started 14 billion years ago. That's one possibility that I think is very plausible. The other, if time is truly fundamental, if time is real and there and inextricable from the fundamental equations, then I think it's very likely that the Big Bang was not the beginning. There's something very profound about the nature of time in our observable universe. Namely that it has a direction, right? That the past is different from the future. And if we can get into this, I hope, the reason why the past is different from the future in your everyday life, the reason why you remember yesterday and not tomorrow, is ultimately because of what conditions were like at the Big Bang. That's what set up the arrow of time, and that's the fundamental mystery of cosmology. There is a much larger universe that we don't see, that our little universe is a tiny little part of the whole picture, and the whole picture is actually symmetric, that there are people in our past who think that we are in their past, that time runs in the opposite direction for them as it does for us.
If space is uniformly filled with an invisible energy, sort of like a uniform invisible mist, then the gravity generated by that mist would be repulsive gravity, which is just what we need to explain the observations, because the repulsive gravity of an invisible energy in space, we now call it dark energy. Dark energy must be infusing space to account for the cosmic speedup. Unified theory of physics, a single overarching framework that would be able to describe all the forces at work in the universe. And the central idea of string theory is quite straightforward. It says that if you examine any piece of matter ever more finely, at first you'll find molecules, and then you'll find atoms and subatomic particles. String theory doesn't quite work. It has internal inconsistencies, a for something wholly unfamiliar. Extra dimensions of space. Shape of the extra dimensions constrains how the strings can vibrate. Maybe each of these shapes is on an equal footing with every other. Each is as real as every other in the sense that there are many universes, each with a different shape.
We don't know. It's a big mystery. Well, the answer is a Higgs-like boson set off the Big Bang. It put the bang